sir.
Voice number. Sir.
Entrance.
Good morning everyone, students. So today I am discussing about this. So NEET and IIT. So today I am discussing about the topic in D block elements. So the most important topic for the competitive exam, especially IIT and NEET and NCET also. So today I am discussing about the D block elements. Periodic table. So what is the importance of the periodic table? Okay, the position of an element. If, for example, you go to any medical shop, so you are purchasing of any medicines, so either paracetamol or aspirin. Okay, so how to find that medicines? So that medicines is also to arrange it in the systematic way. Okay, that's why so that person is easy to identify to get the medicines. Okay, similarly, so nowadays up to 118 elements are so discovered. Okay, so all the elements they cannot be studied at a time. Okay, so how to study these elements? So that's why that time so many scientists are to propose the classification of elements. Okay, so Dovreiner and Mendeleev. Okay, so Luther Mayer, and finally the mostly was proposed by this periodic classification. So in the periodic classification, based on this, enter into the electron into the orbitals. So there are 4 types of orbitals are there: s orbital, p orbital, d orbital, and f orbital, right? So s orbital in the left hand side of the periodic table, in the s orbital. So the completely metals are filled into the s orbital. This is the s block. This is the s block. So s block means the completely metals. So that is also called as the alkali metals. Okay, so that is a different topic is there. The next one is the p block element. These are the p block elements. In the s block, how many electrons are there in the s block? So s block there are 2 elements are there. That's why 2 groups are present in the first A and second A group. The first A group elements are called as the alkali metals, and second group elements are also called as the alkali earth metals. So these group of elements, all the s block elements are completely present in these metals, right? The first A group elements is also called as alkali metals. Those metals are obtained from these, the plants of the ash. So whenever to burn the plants, so one type of metals are extracted. That metals are called as the alkali metals. So alkali metals are highly reactive. Okay, so these metals are completely present in the S block. So there is the first A group. The second A group elements also called as alkali earth metals. Okay, so these are the completely in S block. So this is already over in these previous classes. Next, we will come into this another block, that is the p block. P block. These p block elements, the p block, p orbitals contain the maximum number of electrons are 6. That's why that p block is also in the 6 groups are present. That is the third A2 and the last one is the 0 group. So p block elements is completely non-metals, and metalloids also present in this p block. Okay, so different groups are there in this p block: third A group, fourth A group, fifth A group, sixth A, seventh A, and 0 group. The third A group elements is also called as a boron family. So it is also fourth A group is carbon family, then nitrogen family, then chalcogens and halogens and noble gases. So here, this is the 60A group, very important in the competitive exam. What is the name of this 60A group? These elements are called as chalcogens. So these elements are obtained from the ore of the metals. Ore of the metals. That's why the name is called as chalcogens. The next, coming to this 7th A group elements, the most important thing, these elements are also called as halogens. Halogens. Okay, so these elements are obtained from the sea salt. That elements are extracted from sea salt. That's why that name is called as halogens. The last one is noble gas. The elements also called as the inert gas, means does not participate in the chemical bond. Okay, that's why that elements are called noble gases. Right? So this is the brief introduction in the S block and P block. So means whenever you go to the periodic table, so in a periodic table, so what is the nature of the periodic table? Here S block is there, P block and D block, in the final in F block. So now I am discussing about these D block elements. Okay, so very important in the D block elements, especially in IIT and NEET, very important. So special characters are there in this D block elements. Okay, very important topic in the D block. Right. So D block elements is also called as transition elements. Okay, so what is the name? Transition elements. So transition elements means the D block elements present between the S block and P block. That's why the name is called as transition elements. Very, very important. So which of the following block is known as transition elements? Okay, so D block elements is also called as transition elements because these elements are present between this S block, what is called S block, and P block. Okay, that's why the name is called as transition elements. Right? So very, very important. The coming to the point here, in the S block, the first A group is there, the second A group, the next one is third A group elements. Okay, third A group, right? So this is the third A group elements is there, third A. So in the IUPAC, this is the third group. In case of that is A, so third A, this is the fourth A, fifth A, sixth A, seventh A, ninth. Okay, so up to how many groups are there in the D block? In a D block, in a D orbital, how many electrons are present? 10 electrons are present. That's why in a D block, so 10 groups are present. So what are the groups? The vertical lines are called as a groups, horizontal groups are called as periods, right? Okay, so in a S block, how many electrons are there? In a S orbital, how many electrons are present? 2 electrons. That's why S block is contained 2 groups. Okay, in a P block, in the P orbital, how many electrons are present? 6 electrons are present. That's why 6 groups are present, right? So based on the entering to the electron, which orbital is electrons are entered, that is called as a group, right? So here in a D block, so especially how many electrons are present in the D orbital? There are 10 electrons are present. That's why in this D orbital, how many groups are there? 10 groups are present. In a question is very, very important. In a D block starts from the group of third B. So what is it called? Third B. Right. Yes. Third B group is started. Yes. Third B, fourth B, then fifth B, then sixth B, and seventh B, eighth, ninth, 10th. This is called as eighth group. This is the eighth group. Okay. So seventh B, sixth B is over. Then seventh B. This is the eighth group. Then first B. The last one is second B, right? So very, very important question. In a D block elements, the starts from the group of third B. Okay. The end of the group is second B. Right? So clear, very, very important. Means, so here third B to second B is ended. Okay? So third B is starting element. So what is the starting element of D block element? That is the scandium. This is the first, whenever that enter into the electron in the D orbital, that is the group. For example, you know, scandium atomic number 21, right? So atomic number is 21. Very, very important. So what is the configuration? Argon 4s to 3d1, right? 4s to 3d1. So that's why outermost electron entered the D orbital. That's why D block. So here D block, how many electrons are there in a 3D group? So 4s to 3d1 means outermost electrons, how many is there? 3. That's why in a 3 group. Means the third B, fourth B, fifth B, sixth B, seventh B, eighth group. There are 3 groups are again classified here. So iron, cobalt, nickel, then second B, first B, and second B. So end of the group is second B, starting group is third B group. So these are called as a D block element. It is also called as a transition elements. These transition elements means the D block elements is present between the S and P block. That's why the name is called as transition elements. The very, very important topic in a D block. So D block elements, the special characters are there. We will go to in S block, completely metals are present, right? We will go to in P block, metalloids are present in the P block. But in a D block, it is a transition elements because of the electron configuration is unfilled. means not fulfilled. So unfilled orbitals are present in the D block. That's why the special characters are there in the D block. So D block elements, the special characters are there. So that is called as the what are the characteristics are there in the D block. So next class I will explain this A block elements. But here now discussing about the D block elements. Clear? So now start. Yes. Yes. So D block elements. So D block or D in a D orbital, how many electrons are present? Please. 10 electrons are present. That's why how many groups are present in the D block? 10 groups are present. So which group started in the D block? Third B started. So end of the group is second B. Okay. So here how many groups are present in the D block? There are 10 groups are present. In a periodic table total how many groups are present here? S block is 2, D block is 10, F block is 6, total 18 groups are present. Right? So coming to the other question is also very, very important. In a D block, so horizontal rows are called as the periods, right? So our rows, the periods is always to represented in the term of Arabic number. So the first period, second period, third period, fourth period, fifth period, sixth period, seventh period. You will go to the periodic table. The shortest period is first period, only 2 elements are present, right? In a second period, so here 2 plus 6, 8 elements, then 8 elements. Next you will come into this area. So D block is entered, that's why 16 elements, then 16 elements, then 32 elements because of this lanthanides are entered here. Okay, then 7th period, so this is a 32, here next one is an incomplete period, that is the 7th period. Okay, so how many periods are there? 7 periods. So question, which period starts from the D block? 4th period. 4th period. So which element started? Starting element in the D block. So that is the scandium. So which group? 3rd B. That is the important questions for the examination point of view. In a D block element, which is the starting metal? Scandium. So okay, in the D block, which of the following is the first group? 3rd B. So why that called in the D block element? These elements, D block elements are why that called in the transition elements. So these elements are present between the S and P block. That's why that name is called as transition elements. Okay. So coming to the point. So what are the properties? So special behavior characters is there in the D block because of this block is present between the S and P block, right? So that's why the special character is there. Okay. Right. So what are the special characteristics of D block elements? Very, very important. So what are the special characteristics of D block elements? Right. The first one is various atomic and ionic size of transition elements. So for example, if you go to the S block or P block, in a group, top to bottom ionic radius is increases. In a period, the left to right is decreases because of entering to the electrons are entered into the different shell. Okay, the distance between the nucleus to outermost shell of electron is called as atomic radius, right? So here atomic radius and ionic size. In a group, in a top to bottom ionic radius is increases. For example, in the period, in a left to right is decreases. But here, for example, this is what is the electron configuration of this D block elements? Yes. Yes, m minus 1 into D. Okay, so 1 to 10. So ns2. General configuration. 1 to 2. Okay, so in atomic radius is different, vary in a, especially in the D block elements. In general, in a period, in left to right, atomic radius is always decreases. Right? But here the special cases are there. In the in very, very important question. So which of the following atomic ionic radiuses are same size of atomic radii? So here in the graph, okay, to be represented in this graph, so especially, so this is the 3D series scandium, 4D series yttrium, and 5D series and lanthanum. Okay, so in this 4D, 5D, and 6D, what happened? So here some elements are identical. Some elements are identical atomic size and atomic radius. So especially, so focus about this, especially these three elements to remember: iron, cobalt and nickel. These are identical atomic radius. Very, very important. Question, very, very important. So which of the following pair is the identical atomic radius? So here what happened? So whenever in a left to right, in the period, so what happened? Outermost electrons are entered to the d orbitals only, right? So whenever these electrons are entered to the d orbitals, what happened? The nuclear charge will be increases. So what happened? So for example, the nuclear charge increases. So your nuclear charges increases. What happened? So outermost electrons are attracted itself, right? So that's why the size of the nucleus will be reduces, right? So in a period, in the left to right, atomic size or ionic radius will be decreases because of entering to the electrons are entered to the same d orbitals, means unfilled d orbitals. That's why the nuclear charge will be increases. So what happened? Wherever the nuclear charges increases, outermost electrons are attracted into the nucleus. That's why the size of the atom will be increases. So in general statement, so here very, very important, the special character is there in the transition elements. So some atomic, some ions, some metals are same identical ionic radius. Those elements to remember to here, very, very important. So iron, cobalt and nickel. So in general, we have talked about that whenever the nuclear charge is increases, same atomic number, so same number of electrons are present in any one ion. So what happened? The nuclear charge increases. Nuclear charge increases. What happened? For example, just to listen one example. So for example, neon is there, neon. Okay, fluorine, fluoride ion, neon. Okay, sodium ion, magnesium ion. Okay, right? So magnesium ion is there, right? So some ions are given. So which is the highest size of atomic radius? Yes. So here whenever the negative positive charge increases, what happens? That electrons are removed means, so the nuclear charge will be increases. The number of protons are increases. Means outermost electrons are attracted to nucleus. That's why the decreasing. So here fluoride to sodium and magnesium, the atomic radius is decreases. Okay, all are 10 electrons, right? So fluoride is also 10 electron system. So neon is also 10 electron system. So all are identical electron systems are present. But whenever the nuclear charge, positive charge increases, what happened? Nuclear means the atomic size will be decreases, right? So here is also in the 10 electron system. In general, but here that iron, cobalt, nickel, same identical nuclear charges. That is a special. In this, especially the what is called nuclear charges, all are equal in this iron, cobalt, nickel. That's why the atomic radius are equal. Next, some examples. Some more examples are given here. So very, very important for the competitive exam. Yes. Yes, very, very important. Yes. So ionic radius. So for example, here iron plus 3 is there, iron plus 2. So whenever the nuclear charge increases, what happens? Ionic radius will be decreases. Means here positive charges. So here iron plus 3 charge. So here plus 2 means, so one electron is removed from this outermost shell. What happens? The nuclear charge is increases. That's why outermost electrons are completely attracted to nucleus. That's why the atomic size is decreases. Means more number of, for example, any one ions, the more positive charges means less atomic radius, more atomic sizes. Okay. So another one is also very important thing in these D block elements, Lanthanide contractions. The Lanthanide contractions. So very, very important. Especially we have talked about that here. Okay. So yes. So the similar size means in general in a lanthanides. So if the lanthanides, the cerium elements is started in the lanthanides 4F series. In general, in left to right, whenever we go to left to right, atomic number means atomic number is increases. But what happened? So whenever atomic number is increases, especially in the lanthanides, outermost electrons are entered to the 4f orbital, 4f orbitals. Means, so does not enter the d orbitals, only in the 4f orbitals or electrons are entered. Okay, that time what happened? That electrons are, outermost electrons are attracted to the nucleus. Means in this 4f electron, especially 4f series, what happened? This is also called as the lanthanides. Atomic size. So for example, starting element like this size, next atomic size gradually decreases. Like this. So this is called as contraction. So especially this phenomena observed in these lanthanides only, that's why it is called as a lanthanide contraction. So lanthanide contraction, so why the elements are lanthanide contract? Okay, so outermost electrons are entered the 4f orbitals. That's why that that electrons, whenever that electrons are entered the 4f orbitals, so nuclear charges increases. Nuclear charge will be increases. So that's why that element will be contracts. In the expression in the 4f series is easily to observe. That is called as the lanthanide contraction. So here the similarity of 4d and 5d transition elements. Yes. So here very important, atomic radii of 4d and 5d elements are almost same size. Okay, very important thing, question very important. So which of the following elements are same size of atomic radii? So very important in the zirconium and hafnium element. Question is given, so in IIT and NEET, number of times this question will be repeated. So zirconium, which element is similar to the atomic radii? So zirconium and hafnium both are same identity. Just you will remember. So 160 picometers, here 159 picometers means both the same identical. So same size of atomic radii is present in the zirconium and hafnium. Okay, so that's why whenever that electrons are contracts, what happened? Whenever electrons are contracts, the nuclear charges increases. Means that elements are very strongly binded. That's why they cannot be separated in any separation techniques in the lanthanides. Okay, so very important. The separation of lanthanides is very difficult because of very smaller size and chemical properties. Yes, what happened in a period? The size of this element will be reduces, decreases. Okay, very important thing. The variation of basicity of lanthanide hydroxides. So very important. This is also very important question. Okay, lanthanum hydroxides is more basic than lutetium hydroxides. Lanthanum hydroxide more basic nature. So because of whenever you go to lanthanum to lutetium, what happens? The size of the atom will be decreases. So easily two OH minus ions are removed. So according to the Arrhenius theorem, so any one aqueous solution to removal of OH minus, that is called as a basicity, right? So your comparison to here, so lanthanum to lutetium, what happened? The basicity will be decreases. So which of the following is more basic nature of hydroxide? Very important. So that is lanthanum hydroxides are more basic than lutetium hydroxides. Lutetium hydroxide due to the smaller size and high polarizing power. Okay, I will explain later what is the polarizing power. Okay, so next one is the order of density. Yes. So density means the mass present by unit value is called as the density, right? So whenever the size, for example, size is the motor size. Okay, so another one is the small size. What happened? So what is the density? Mass present in unit value. So whenever volume decreases, the density of the metal will be increases, right? Yes. So here, yes. So here titanium, zirconium, hafnium. So which is the highest density? Hafnium is more density than titanium and zirconium. So because of atomic size is decreases. Similarly, copper and silver and gold. Gold is the more density in a periodic table. So which is the more denser metal in this periodic table? That is gold. So very important, the lanthanide contraction. So whenever outermost electrons are entered to the f orbital, what happened? That electrons are attracted to the nucleus, means the nuclear charge will be increases. So finally, the size of the atom or element will be reduces. So whenever the atomic size is reduces, what happened? So that element, it is contains smaller size and more density is there, and also less basic nature. Okay, so that is the most important thing in the Lanthanide contraction. In a which period, which series to observe in this Lanthanide contraction? That is the 4F series. Okay, so very very important concept. So whenever the nuclear charge increases, what happens? The atomic radius decreases. So more positive means less atomic radius, less atomic size, right? So very very important concept, the Lanthanide contraction. Okay. The next one, another property of D block elements. So especially D block is a special characters are there. So magnetic property, different oxidation states. Okay. So next coming to this another property. Yes, oxidation states of D block elements. Right. So D block elements, the different oxidation states of behavior. For example, you go to the first A group elements, the general oxidation state is +1. You will go to second A group elements, that is oxidation state is +2. In the third A group, +3. Fourth A group, +4. Okay, so after them, sixth or seventh A group, 8 minus the group number, that is the oxidation state of that group. Right? Here, these D block elements, so unfilled orbitals are present in this D block. That's why these elements are to behave in a different oxidation states. So the third, for example, just to observe in this 3D series, this is the 3D series. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt and nickel. So very very important. So scandium only +3 oxidation states. Yes. So zinc only +2 oxidation states are behaving. So very very important. So which of the following elements, they cannot be shown in different oxidation states. So only 2 elements are present in the D block. Number 1 is the scandium and zinc. So scandium is always to show the +3 oxidation state and zinc is +2 oxidation states. Then copper oxides are there. You know copper oxides. Cupric oxide is there. Cupric oxide and cuprous oxide. C2O, right? So this is the +1 oxidation state is there. This is the +2 oxidation state is there. Means copper 2 type of oxides are to behave here. +1 and +2 oxidation states. So very very important, you know, copper atomic number is 29, right? Copper atomic number is 29. So write the configuration: argon 18, 4s1, 3d10, right? Yes. So whenever to behave in a copper +1 oxidation state, so 4s0, 3d10 means fulfilled orbitals are more stable than unfilled orbitals. Okay, according to yes. Oh yeah, Hobbo principle. So Hund's principle, Hund's rule. So off-field or fulfilled orbitals are more stable than unfilled orbitals, according to the Hund's rule. So here, cuprous oxide is more stable than cupric oxide. Very very important question. This question is repeated a number of times in the examination. So which is the most stable? Cuprous oxide is more stable than cupric oxide. Due to cuprous oxide, the oxidation state is +1. +1 means this electron will be removed, means that time. So this is a 0, 4s0, then 4d10. So this is the cuprous oxide oxidation state, electron configuration. Okay. So a different type of elements are there in different oxidation states. In this periodic table, in a D block element showing the highest oxidation state in the 3D series is +4. That is the potassium permanganate, KMnO4. Potassium permanganate is a pink color in general, pink color potassium permanganate. Because of this potassium permanganate, to show this one type of transitions are there, that is charge transfer. Okay, so charge transfer and also called as what is called charge transfer spectrum is observed in this potassium permanganate. That's why this is the color of compound. Okay, I will explain the color. So your highest oxidation state in the 3D series, that is the +7, that is the manganese element. Manganese element is highest oxidation state is there in +7. You will go to this +7 to here, zinc gradually decreases. Okay, so very very important. You will go to a periodic table. So a D block element shows in highest oxidation state. In general, in the D block elements, okay, to form these, especially oxygen and fluorides, because of oxygen and fluorine elements are more electronegativity than other elements. Okay, so here in this, especially you will remember to ruthenium tetroxide and osmium tetroxide. These elements are, okay, so ruthenium tetroxide and osmium tetroxide, especially these two oxides, to show the highest oxidation state in this periodic table. Very, very important. So here oxygen is always -2. That's why ruthenium oxidation state is +8. +8. Similarly, here osmium is also +8 oxidation state will be observed. Very, very important. Yes. In this periodic table, which of the following element to show the maximum oxidation states? That is the ruthenium and osmium. Okay, so ruthenium and osmium, so ruthenium tetroxide and osmium tetroxide to show the +8 oxidation state in the periodic table. Okay, so this is the oxidation state. So why that this type of oxidations are to form? Because of the general configuration of these D block elements already done. So n-1 D 1 to 10 and ns 1 to 10, 1 to 2, right? So this is the 4s, a 3D series general oxidation state like this. Okay, but here, for example, you will go to in 3D series. What is the configuration of 3D series? n-1 D 1 to 10 ns 0 to 2. 0 to 2. Special calculation, special oxidation states are there in the 4D series. Okay, so this is the 3D series, the general configuration, right? But in the 4D series general configuration is n-1 D 1 to 10 and ns 0 to 2. So special characters are there in the D block elements. So unstable means unfilled or fulfilled orbitals are more stable than unfilled orbitals. Okay, so that's why. So here the 3D series, especially, so you talk about the palladium element. The general configuration of palladium is, yes. So here 4D 10, okay, 5s0. Means special oxidation state is there in the palladium because of the d orbitals or 5 subshells are there. Each subshell to occupying the 2 electrons, 5 2s are 10 means d orbitals are fulfilled with each orbital in the 2 electrons. Fulfilled orbitals are more stable than unfilled orbitals. That's why this palladium to behavior in the oxidation state is very, very important. So last time, I think 2014 NEET question. So palladium. So what is the electron configuration of this palladium? Outermost shell of electron configuration of the palladium 4d10 5s0. Okay. In general configuration, we have talked about these D block elements. So n and n-1. So D 1 to 10 and ns 1 to 2. But here, so palladium special character is there. You know already, I think. So chromium. Okay, argon 4s1 3d5, and copper is also yes, argon 4s1 3d10. So different electron configurations are there. So why that D block element to show in different oxidation states? Because of to get the stability. Yes. So for example, so d orbitals are off-filled means d5, or full-filled orbitals are more stable than unfilled orbitals. That's why D block elements are to show in the different oxidation states. Yes. Special, very important thing in a oxidation states of D block elements. In general, oxidation state of these D block elements is +2. +2. General oxidation state of D block elements are +2. So because of s orbitals are s block is 2 groups are there. So general oxidation state, the definition to show that all the elements +2 oxidation state to observe, except to scandium, all the elements are to show the +2 oxidation states. That's why what is the general oxidation state of D block elements are +2. Okay, so this is also called as the transition elements. All the transition elements are also called as a D block elements, but it's not all D block elements are transition elements. So especially we are talking about that here. So yes. So this is the first B group element, right? The first B group element is there, zinc, cadmium and mercury. Zinc, cadmium and mercury. So you have to take that any one element. So these element outermost orbital, d orbital is full filled, right? Full filled, yes. Except first B, all group elements are, so second B, except second B, all the elements are unfilled d orbitals. That's why that elements are called as a transition elements. What is called? Transition elements. Except second B. Second B group element is also called as D block element. What is called? D block elements. Very, very important. So which are the following D block elements? Only second B. What are they? Zinc, cadmium and mercury. Why they are called second B group elements are called D block? These elements are full filled of electrons in the d orbitals. So except these secondary, remaining all the group means how many electrons are present in this generally how many series are there? 4 into 10, 40 elements, right? Except 3 means out of 3. So remaining 37 elements. Okay, so except these 3 elements, remaining 37 elements are called as the transition elements. Only these D elements are called D block elements. What are the D block elements? Zinc, cadmium and mercury. Right? So very, very important. So what is the difference between the transition elements and D block elements? All the transition elements are called as the D block elements, but all D block elements are not a transition elements. That is the important thing. Right. Yes. So this is a general idea talking about this in competitive exam. Various oxidation states in the D block elements. Yes. The D block elements can exhibit more than one oxidation state, right? For example, iron exhibits in +2 and +3 oxidation states. Exhibits in +2 and +3 oxidation states. Okay, so +3 is more stable than +3 is more stable than +2. So because of you write down the configuration, so iron +2 means what is the oxidation state of iron +2? So what is the configuration of iron +2? Yes, 26, right? Argon 4s0 3d6, right? Then we'll go to in ferric oxide or anyone. So iron +3 oxidation state is present. So we'll write down here configuration argon 4s0 3d5, right? Yes, d orbitals are unfilled is there, off-filled orbitals. Off-filled orbitals are there. Okay, so off-filled or full-filled orbitals are more stable than unfilled. Therefore, the stability. So which is the most stable of iron oxides? Fe3 is more stable than Fe2+. So okay, this is a very, very important question to expectation of any NEET or IIT JEE. Very, very important. Why that Fe3 is more stable than Fe2+. So okay, so Fe3 is off-filled orbitals are more stable than unfilled orbitals. Okay, so that is the suitable answer. Some important examples are there. Cadmium only +3 oxidation states. Yes, +3 oxidation state. Then titanium, the different oxidation states already before the previous series. Vanadium, chromium, manganese, iron. Okay, so copper 2 type of oxidation states. Zinc only +2 oxidation states. Okay, it is not a transition element. So zinc is a which type of element? D block element. It is not a transition element. Nothing but all the transition elements are D block elements, but not all D block elements are not a transition elements. Okay, so the various oxidation states are observed in these D block elements because of d orbitals are unfilled orbitals. Right? So very, very important. So iron is more stable than iron +2 because of unfilled orbitals are more stable than off-filled orbitals are more stable than unfilled orbitals. Yes. The next character is the property of D block element is formation of color ions. Very, very important. The formation of color ions. So D block element to show the different colors because of 3 characters are there. Number 1 is unfilled electrons results in DD transitions. You will go to the higher education, the different type of transitions are there. Okay, so DD transitions is octahedral complexes, tetrahedral complexes, square planar complexes, different complexes are there. But here, whenever d electrons are transferred. Okay, so these electrons are transferred from one shell to another, means one energy level to another energy level. So why that the compounds are colored? Because of light will be absorbed, then transmission in all the directions. Okay, so yes, you know scattering of light. Okay, why that sky is blue color? Because of scattering of light, right? So some amount of light will be observed in the form of quanta. So some amount of energy are transmitted in all the directions in the form of quantum. Okay, that's why the colors are observed here. So unpaid electrons, very important. So whenever the color compounds are observed, so this is the color compound. So examination point the most important at the NEET or IIT, which of the following is colored ion? Simple, we have identified given the ion, either the unpaid electrons are present or not. If the unpaid electrons are present, what happened? That electron will be transmitted from one energy level to another energy level. So the higher education TGTWREIS level and EG level. It is a crystal field stabilization theory. Crystal field stabilization theory. So whenever the light energy is observed, what happened? The d orbitals are split because of d orbitals are 3 orbitals are symmetrical, another 3 orbitals are unsymmetrical. Okay, that's why these orbitals are split to T due to EG level. Okay, so whenever that light energy is incident on this d orbital, what happened? These electrons are shifted from one level to another level. Means some amount of light energy will be absorbed and then transmitted. So that's why the compounds are to show in different colors. So to remember examination point of view up to intermediate level. So why the D elements, D block element to show the color ions? The first to remember unpaid electrons are present, that is the D transition. Second thing, charge transfer spectrum. Charge transfer spectrum. The charge transfer spectrum, there are two types. So here for example, so one metal is there, another one is ligand there, right? One metal, another one is ligand there. So some amount of light transfer from metal to ligand and ligand to metal. So that time some amount of energy will be absorbed and transmission. That is called as charge transfer spectrum. Only charge will be transferred. So charge transfer, there are two types. Number one is metal and ligand. Metal to ligand is there. Another one is the ligand to metal. So this is completely Weber's theorem. I will explain later. So what is the metal and ligand? So that is a different topic. So this is called as a charge transfer spectrum. So charge transfer spectrum. So for example, you know, so copper oxides are blue in color because of, so here metal to ligand transfer. The transfer of energy from metal to ligand, that is the because of oxide. So because it is a type of blue color, right? Radiation blue color. Next, another one is ligand to metal transfer. So this is all the type of compound. There is no d electrons, right? Before I talk about that, why that elements are colored compound? Because of unpaid electrons, that unpaid electrons are transferred from d transition. But here there is no d electrons. Why that these compounds are to show in a different colors? So here potassium bromate, orange color. Okay, so potassium bromoxide, so yellow color. Potassium permanganate, purple color. Plus oxide, okay, red color. So why that colors are different? So examination point of view very important. Match the following. So what is the color of these compounds? So why that these compounds are to show the different colors? Because of charge transfer spectrum. What is it called? Charge transfer spectrum. The next one is polarization power. Whenever the polarization power is increases, what happens? The darkness will be increases. For example, so you know halogens, fluorine, bromine, iodine. What happens in a group top to bottom? The polarization power will be increases. Meaning the size of the ion will be increases. So whenever the ion size increases, what happens? The polarity means polarization increases. You know polarity. This is concept to completely explain in the 10th class intermediate first year dipole moments. Okay, so dipole moment, the polarization power to the complete concept to explain the dipole moment. So how to calculate the dipole moment with the help of polarization. Yes, fluoride, chloride, bromide, iodide. What happened? The size of the anion increases, right? So whenever the anion size increases, polarization power is more. For example, you know HCl, hydrochloric acid. So in this hydrogen very smallest size, but you have chlorine the largest size, right? So here chlorine is more electronegative than hydrogen. That's why these bonds shifted to here. That property is called as the polarization. So here fluorine to chlorine, bromine, iodine. What happens is the fluorine size, the chlorine, bromine, and iodine. So this is the bromine and iodine. What happens? The polarization power increases. Polarization power, whenever polarization power increases, what happens? Darkness will increases. Yes. For example, fluorine, pale yellow, light yellow color is there. Chlorine, greenish yellow color is there. Means small changes. Because of different wavelengths are there, different colors. Why the different colors are there? Because of different wavelengths. Next, reddish brown colors appear. The last one is the dark violet color. Means whenever the polarization power is increases, what happened? Okay, the ionic size increases, polarization power. So ionic size increases, what happened? The polarization power also increases. So whenever the polarization power increases, what happened? The dark color will appear. Means here very important. D block elements to form a formation of different colors. Color ions are formed. Okay, so due to the three parameters are there. Number one, unpaired electrons. Whenever unpaired electrons are present, what happened? D transitions are formed. So if you go to any common exam, so ions is given, unpaired electrons are present. Why that these elements to show the colors? So that time talk about that electrons whenever light will be incident on this ion, what happened? That electrons are to rotate. The electron will be what happened? Energy will be absorbed, then transmitted. That's why that matters that ions are to show the colors. Okay, that is called as DD transition. Next one is charge transfer spectrum. Yes. So lanthanides are smaller sizes are there. So whenever lanthanide is smaller size, one ligand is nothing but acting as a Lewis base. So ligands are acting as a Lewis base. Metals are Lewis acids. So Lewis base, what happened? Electrons donate to the metal. Metal cancels, right? So that time that ligand to attract to bind the metal. Okay, that time.
చెప్పలేదు కరెంట్ పోయిందని చెప్తే ఇంకా అయిపోయా
బ్రేక్ మేడం అది కరెంట్ పోయినప్పుడు టీ బ్రేక్
ఏమైనా కరెంట్ పోయిందని చెప్తే ఏమైతే
యూపీఎస్ తెప్పించారు సార్
తెప్పించి
కనెక్షన్ ఇవ్వలేదు ఇంకా
అదే
అలాగే
The next one, the formation of colored ions. Okay, so already over. The color ions are depends on the number of unpaired electrons. Okay, in the DD transition. The second one, the charge transfer spectrum. The third one is polarization power. So the last point is already over. So what happened? So when the polarization is depends on the size of the anion. So when the size of the anion increases, what happened? The polarization power increases. When the polarization power increases, what happened? The darkness of the color will be increases. Okay, so this is the special character, the special property of these D block elements. Okay, so very important thing. So what are the characteristics of the D block elements? The next one is, so some color compounds are there, very important. So directly, so very important. So some colors are there in NEET and IIT examination. The formation of colored compounds. So here very important topic. Yes. So here titanium and copper and nickel and manganese. The different colors are appeared here. here. So the titanium, so this is called as a ligand. Okay, so hexa aqueous. So titanium complex. So hexa-aqueous titanium complex is the purple color. The next one is, so the copper is always in blue color. So very very important. So copper metal in general, so without means what is called, so dried copper is colorless, but the aqueous copper is a blue in color because of, so 5 water molecules are coordinated around this copper metal. Okay, so in copper is always in blue in color, very very important, copper salt. The next one is nickel is the green color. Okay, manganese is the purple color. So very very important, just students, very very important that to remember the match the following of this complexes. Okay, so this complex compounds, the titanium compounds, so copper and nickel and manganese. So it is a different colors are there. Okay, because of so different factors are explained. Number one is the DD transition and charge transfer spectrum. Third one is the polarization power. Okay, so next, so here, so DD transition to explain by the crystal field stabilization theory. So crystal field, so when the light, so already I have explained in the previous class, so when the light is a incident on this compound, what happened? So d electrons or light will be observed then transmitted from higher, so low level to higher energy level. So that time what happened? So that time, so energy will be transmitted. So that phenomena is called as the DD transition. DD transition, very very important. So very very important question here in this NEET and IIT exam. So copper plus 2 salt, hydrated copper 2 plus salt is a colorless. Okay, so dried copper plus is yeah, salt copper plus is colorless, but hydrated copper 2 plus is blue or green. Okay, so due to this, so why this compound is will be colored? Because of copper plus 2 ion in a hydrated means, so copper sulfate here 5H2O, 5 water molecules are coordinated around this copper metal. Okay, so this is called as a blue in color, copper sulfate. So copper sulfate, whenever to add these 5 water molecules, what happened? The color will be appeared. So this copper sulfate solution, whenever to heat it, this copper sulfate solution, what happened? Colorless. So because of 5 water molecules are loose from this copper. So here 5 water molecules are whenever to coordinated with this copper metal. So copper sulfate to show the blue in color, very very important. Next one is iron plus 2 salt. So iron plus 2 is light green. Iron plus 3 salt is yellow and brown. Okay, so very very important thing. So light green color is there. So but here, so iron plus 3 is the more stable salt to get the yellow or brown color. Chromium complexes green and or violet. Okay, so zinc and cadmium is colorless. Hello. 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 Hello.
మాట్లాడండి.
హలో,
ఎనీ డౌట్స్?
ఎనీ డౌట్స్? హలో స్టూడెంట్స్, ఎనీ డౌట్స్? స్లైడ్ క్లారిటీగానే ఉంది.
స్లైడ్ ఉంది. మీరు కూడా కొంచెం స్టార్టింగ్ కంటే చాలా చేంజ్ వచ్చింది. సార్ ఐఎమ్ ఎండింగ్ ది సెషన్.
అంతేనా? ఓకే.